All right, so I got smart. I actually gave myself a lot of space for these questions now. So in question three, kind of a tricky one, right? So what we can do here is logarithms tend to be really, really helpful in terms of taking integration by parts. So if I let u equal, I'm going to go with the natural log of x whole thing squared here. Right, we're going to see this is actually a really nice, easy thing to take a derivative, which is going to help us out. So dv is going to be 1 over x cubed dx. All right, so when I take the antiderivative of 1 over x to the third power, we're going to end up with negative 2 over x squared. And when we look at the derivative of u, right, so when I take the derivative of natural log squared, we would use a chain rule here, 2 natural log of x all over the derivative of natural log of x, which is x. All right, so let's put those things together. Right, we would have this. I'm going to worry about my limits of integration much later. Hold on, this is stupid. This is stupid. This should be 1 over negative 2, right? We'd have x to the negative third. So when I take this antiderivative, we're going to get x to the negative second power all over negative 2, right? So my bad. So then u times v is going to give us, I'm not even going to try to write those things anymore. It's too late at night for me to care about this. So we're going to get u times v, natural log of x squared over 2x squared minus v du. So we're going to get there's a negative in here. So we're going to get negative 1 over 2x squared times 2 natural log of x over x dx. We can cancel a bit. This cancels, that cancels. And so this part here just becomes plus natural log of x over x cubed dx in this antiderivative, and this is here. All right, so then again, we have another integration by parts. It doesn't seem like we did too much, but notice that our natural log of x squared is now just a natural log of x, right? So we reduced it down by 1 order, which is a great thing. So again, we're going to say let's let u equal the natural log of x. And again, let's let dv equal 1 over x cubed dx. So v is going to equal negative 1 over 2x squared, like it did a moment ago. And du is going to be 1 over x dx. All right, so then this term here is going to end up being, I got it. This term here is going to end up being u times v. So we're going to get negative natural log of x over 2x squared when I multiply those two things, minus the antiderivative of v du. So we're going to get negative 1 over 2x squared times 1 over x dx. Right? Again, we can kind of clean things up a little bit. Right, so this is going to stay. This is going to stay. And then this last term is going to be now plus the antiderivative of 1 over 2x cubed dx, right? So I can pull that 1/2 out. And we'll just get 1 over x cubed, all right? So then now this is something we can take the antiderivative of. I can't even draw a brace. I cannot even draw a brace. It is so late. I've lost my ability to draw braces. So we're going to take the antiderivative of 1 over x cubed, and we're going to end up with 1 over negative 2x squared times that 1/2. We have a minus natural log of x squared over 2x squared minus natural log of x over 2x squared. And we're going to have when I simplify this thing, we're going to end up with minus 1/4 x squared. Right now, let's not forget this was a definite integral. So we're going to evaluate this thing between 2 and 1. So the good news is that our natural log of one things are going to just disappear. So we're going to end up with negative natural log of 2 squared over 2 times 2 squared, which is 8, minus the natural log of 2 over 8 again, minus 1 over 4 times 2 squared is 1/16. So we have this. Then we're going to take away, right? Natural log of 1 is just 0. So we're going to get 0 minus 1/4 times 1. So this would be our antiderivative. We're going to end up adding 1/4 on. So if I have negative 1/16 and I add on a fourth, which is 4/16, I'm going to end up with positive 3/16, negative natural log of 2 squared over 8 minus the natural log of 2 over 8 plus 3/16 would be our antiderivative, our definite integral, our area.